What's up, baby birds? Today we're going to be starting our third unit. This is going to be talking about the law of cosines, the law of sines, finding the area of triangles, and vectors. So let's start with the law of cosines. Now, if you guys remember, what you learned about the law of cosines is that there's only two situations that you could use it in. See if you can beat me to it, but these two situations are side, angle, side triangles, and side, side, side triangle. So the first step to any one of these problems, because they're not going to tell you what kind of triangle it is to figure out what kind of triangle you have. So let's take a look at our first example problem. If you look at this one, you have a side over here, an angle over here, and a side over here. So you have two sides with this angle in between them. So this would be called side, angle, side. So I know I can use the law of cosines. Well, from here it's just easily, I'm going to just have to plug it in. So since I'm looking for C, I'm going to plug into my formula over here for the law of cosines. But I don't plug it in exactly as it's written. Remember, I always put the missing side at the end. So the way we're going to plug it in is C squared equals A squared, because we do know what that one is, plus B squared minus 2AB cosine C. So it's just important to recognize that whatever you're missing is always going to be here. I'm missing C, so it goes there and there. And the ones, there we go. And the ones that I know are going to be over here, okay? So remember, the missing one always goes over here. Now, since I know 8, 12, and 40, let's plug it all in. So I know over here, this is going to be C squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of 40. How do I know it was 40? Because if you look, the opposite of C is 40 degrees, so that would be angle C. That's why it goes in there. All right, now what I'm going to do, you can follow along, do this with me, is I'm just going to plug this exactly into my calculator as it's written. So I'm putting in 8 squared and so on and so forth. Okay, if you plug this into the calculator correctly, you should have gotten 60.9195. The final step to solving is just taking the square root. So we take the square root, we take the square root, and we just get C equals 7.8. And you know what? Let's just round it to the nearest hundredth, 1. Now, if you're wondering where to round to, it will always be specified in the question, so don't worry about it. Here, I'm just rounding to the nearest hundredth. Now, our second example here is a little different. This is where we have 3 sides. So this is a side, side, side triangle. All right? Now, oops, I forgot to put the question, but let's say we're looking for C, okay? Well, that's what you should be doing for this. Let's find C, all right? If you are looking for C, the way to do that is this. Well, C is our missing angle, so we're going to say C squared. Remember, whatever we're looking for just goes over there, equals B squared plus A squared minus 2BA times cosine of C. Okay? Now we just plug in. So C, remember, it's always opposite the angle. So C is here. So opposite that is 9. So we're going to plug in 9 squared. 9 squared equals A, which is opposite A is 11. Oh, sorry, B. Sorry, opposite B is 12 squared plus A, which we already said is 11 squared, minus 2 times 12 times 11 times the cosine of C, and I don't know what C is. That's the angle we're looking for. So we just leave that. That's our variable, basically. All right, the next thing to do here is there's 3 things you have to do. You don't just put this all in the calculator. Here's what you can do. First one, square this, okay? So you get 81. Second one, square these and add them together, okay? So that's 144 plus 121. So you should get 265 minus, let's see, this is 2 times 12 times 11, 2 times 12 times 11, just doing it on the calculator, okay, minus 264 cosine C. So be very careful here. All you have to do is three things. Square what's on the left side of the equation, square these and add them together, and multiply these together, okay? Don't do anything else. Now, you don't subtract these two. Don't do that, okay? Because these aren't like terms. This has a cosine C, this doesn't. So you can't just subtract them. To solve, you're going to have to subtract 265 from both sides. So we subtract 265 from both sides. So 81 minus 265 equals negative 184. So we do that. And that equals negative 264 cosine C. We divide now, because we're solving for cosine C, so I divide by negative 264, negative 264, divide by negative 264, and we get a fraction. So this would say this. It's the cosine of C equals 23 over 33. Finally, what do we do to solve for this? Well, if we want to know the angle, but we know the ratio, remember we take the inverse sine. So we get the cosine negative 1 of 23 over 33. Oh, sorry if I'm going off here. Equals, well, let's put in the calculator. Trig cosine, and that 23 over 33. And you should get about 45.8156 degrees. So sorry for the messy handwriting, but that should be your answer. Okay, so those are the two cases of the law of cosines. Let's look at the law of sines. This one, it's a little simpler. So this one is, when do we use the law of sines is what you're asking? I will tell you. The law of sines is used, well, when you have angle, side, angle. When you have angle, angle, side. And let's see, is there anything else? Oh, yep. And when you have side, side, angle. These are the three situations where you use the law of sines. Okay? Remember, that's important. The first step is identifying. So in triangle ABC, the measure of A is 25 degrees, the side A is 12, and side B is 9. How are we going to solve this? Well, first thing to do is to draw our triangle, all right? And we can just arbitrarily label ABC. Doesn't matter where you put it, A, B, C. We know this angle is 25 degrees, all right? We know this side 12. Remember, it's very important how you label things. Side A is 12, and B is 9. All right? Once again, the question is not exactly written here, so let's say I'm going to try to find out what angle B is. Okay? So if we want to find out what angle B is, what do? We have to set up our ratio. So it's A over sine A equals B over sine B. So it's the side, 12, over the sine of the side, sine of that side, equals B, which is 9, over the sine of angle B, sine of B. So the angle over here is our variable. That's what we're trying to solve for. And what we do from this point, once we have it set up, is just cross multiply. So we get 12 sine B equals 9 sine 25. All right? You see what we did there? We just cross multiplied, cross, cross. Okay. From here, we just put it into the calculator. What we get from 9 times sine B? Let's see. 9 times sine 25 equals 3.8. I'm just rounding it there. So 12 sine B equals 3.8. Let's move this down just a little bit. All right. From here, since we're solving for sine B, we're going to divide both sides by 12. So we're going to divide by 12, divide by 12, and we get sine B equals, let's see, 3.8 divided by 12, 0.31. Once again, I'm going to just round it, 7. So you should round the same. And finally, because we're looking for the angle, and we know the ratio, we just have to take the inverse sine. So we do the inverse sine, sine -1 of 0.317, and we get 18.4816 degrees. And that is how you do the law of sines. Remember, for the law of sines, you just got to cross multiply and solve for your variable. All right, so your answer is right here. Keep moving. All right, finding the area of triangles. This one's really straightforward, okay? You just basically have to plug into the formula. The only thing you have to know is that when you find the area of a triangle, it must be a side angle side triangle, okay? So for this one, all you have to do is say that the area is equal to 1/2. Well, our first side is 12 times the other side is 20. 20 times the sine of 80. Once you've done that, you just put it directly into your calculator. So I'm just going to do that right now. So once you plug it into the calculator, all of this should be your answer right here. Okay? Now, when you have a parallelogram, remember, it's the same idea, except then you have to just draw a line. So you have a side angle side triangle, side angle side. All right? You find out what the area of this side is, and you just multiply by 2 because these are two congruent triangles. Done. All right. The law of sines, the ambiguous case. Now, this is the one where you had to see how many the answers there are. Well, I'm not going to do this whole problem. I'm running out of time, and I don't want to take too much of your time. But this is what you do. You set up the law of sines, okay? So it's going to be 59.2, that's side 1, over the sine of the angle, 74, all right? So I'm just setting up. Equals 60.3 over sine C. Now this is the angle we're looking for, and we want to find out if there's 1, 2, or 0 possibilities for that angle. So we're going to do the law of sines. I'm not going to record it. Just try to figure it out yourself and see if you get the same answer as I. So if you did this correctly, you should have gotten the sine of C equals 0.979123. Take the inverse sine of that, and we should get that C equals 78.27 degrees, and I'm rounding it. And if you got something close to that, you are correct, okay? That just is a rounding error, okay? So it's about that much. From this point, this is what you do. So you have two possibilities, okay? So we're going to say angle 1 is equal to 78.27, and we know that's a good angle, all right? Now you have to see if there's a second possibility. So angle 2, to do this, you just have to do 180 minus 78.27, all right? This is how you find your second angle. You do 180 minus that angle every time. All right, so your second angle should have been 101.73. I'm rounding there again, okay? That's your second angle. Now we have to check to see if this angle actually works. The way to do that is this. You go to your first angle, so this is your check, okay? And you have to say, is my original angle, measure of angle A, 74, plus this obtuse angle, 101.73, less than 180 degrees. Like, does it fit into a triangle? All right? So if I do the math here, you get 175.73 is less than 180. Since this is true, this is our second possibility, and these are our two triangles. Oh, and Mr. Siegel got it wrong because he forgot to read the question to the nearest tenth, so you have to round these. So this is 78.3, and this is 101.7. They will take off on the region, so please be careful on that one. All right, the last one, I just want to be clear about this. I only have 10 seconds before it cuts off. But if you read this question, I just need you to do this. When you fill this out, just know that this, you fill in force 1 goes over here, force 2 goes over here, and the angle is